This is Seymour Rocks from Down Under. I've already reported on this once before on my blog, but I'm just wanting to do a bit of monitoring to see how the situation has changed. The article I wrote was to try and explain how it is possible for, well, not only for methane to be coming out of the permafrost here and into the Arctic Ocean, but also it's coming from down below, primarily in the area of Nowe Zemlya, but also elsewhere in the eastern Siberian shelf. So I'm just going to be looking at some of the temperatures as they are at the moment, and it's pretty amazing to find that Null School is giving these sea surface temperatures, and I have to assume that they're accurate. So that's why I'm using it. So for instance, there's a warm area here, which is as high as 16.3 degrees Celsius. Now that is 61.3 degrees Fahrenheit. Now that compares that 16.3 in the middle of winter, and I did a comparison in New Zealand for Cook Strait between the North and South Island of New Zealand in the middle of summer in the midst of a marine heat wave, and the temperatures there were between 17 and 18 degrees. So that is not a huge difference, and it's absolutely amazing that we should have this, well, albeit quite a small area of warm water. And there's also one up here which is about 8.1 degrees Celsius. That's 46.6 degrees Fahrenheit. So, there's some really warm areas. Now, the colder water around Svalbard is minus 1.4 degrees Celsius. Now, that's not warm enough for ice to start forming. It freezes, if my memory serves me correctly, at about minus 6 degrees Fahrenheit, or about minus 21. So that's, and especially in this Atlantic area, there's a lot of seawater, and so the ice is going to start forming at a much lower temperature than it would if it was pure water. So if we go up to Nowe Zemlya, the temperatures here are, that's 0.1 degrees Celsius. Now that's above freezing. That's 32.2 degrees Fahrenheit. And we just go up the coast, so 0.6 of a degrees Celsius, 0.3. Now that's just above freezing. And now we've got to minus 1 degrees Celsius. That's 30 degrees Fahrenheit. And goes to minus 1.4. And then if we go around on the eastern side, minus 1.4, minus 1.2, and minus 1.1. So it's a little bit cooler on that side, but nevertheless there's been a lot of methane coming up, especially on that side of Nowe Zemlya. And I just noticed that there is this little bit here. Let's just see what that is. Oh, wait a minute, no, it doesn't give that, because it only gives sea surface temperatures. Never mind. So now if we go down to, well, let's have a look at the Bering Strait, about minus 1.5 degrees Celsius, 1.8. And if we go to the North Pole, that's also 1.8 degrees Celsius or 28.8 degrees Fahrenheit. And we'll just look at one other area. If we go down sort of south of the Bering Strait, minus 1.3, minus 1.8, minus 1.8. So the sea surface temperatures are pretty high, and it would be quite interesting to do an exercise and compare that with the waters around Antarctica, and I may do a video on that sometime soon. So the conclusion is that it's not at all surprising that we're seeing methane coming up, and there is ice there. The integrity, I'm surmising, is quite low, but just imagine if there was no ice. I would surmise that methane is coming up through the water column. Only a very small amount of it would actually come up into the atmosphere at surface level. So that doesn't bode very well for next northern summer. Anyway, that's me for now. This is Seymour Rocks reporting from down under.